All right, what's up, homeboys and homegirls? It is Coach Jakes back with another video that's gonna make your chemistry life easy. All right, check this out. In this video, we're gonna be talking about Charles' law. So if you're in your gas laws unit, this one might be a good one for you. All right. So in Charles' law, we're examining the relationship between volume and temperature. So we're basically looking at how volume and temperature affect or impact how a gas behaves or what a gas does. All right. And so most of these laws are like this before and after thing, initial, final, before, after, at the beginning, at the end. Those are words you need to kind of tune into because when you get down to your word problems, these words matter. Okay. So initially we have this balloon. The balloon has a volume of 5 liters and the temperature is 200 Kelvin, right? So now this is the before. Now what we're saying is if we change the temperature from 200 Kelvin to 400 Kelvin, right? Then according to Charles' law, we know that the volume is also going to increase. Not only will it increase, but you see how 200 to 400, it doubles, right? The volume will also move proportionally to how the temperature increases. So what we say is that this Charles' law is directly proportional because they move in the same direction. As this one increases, as our temperature increases, our volume increases, and they're going to increase and decrease by the same ratio. All right, so that's why we say it's directly proportional. I left out the O. So it's directly proportional. Okay, and so the formula for this is V1 over T1 equals V2 over T2, where the ones mean our initial or the beginning, and the twos mean our final or at the end or our resulting. Okay, because everything again is before and after. So this is our before, this is our after. So initially, our volume was at 5 liters and 200 Kelvin. When we changed our temperature to 400 Kelvin, our V2 then becomes 10 liters. Let me do that. I like that. So 5 liters would be my V1. 200K would be our T1. 400K would be our T2. And 10 liters would be our V2. All right, so now when you're given this formula, that means you're going to be solving for one of these variables, either V1, T1, T2, or V2. All right, but they're directly proportional. So just keep in mind, if one of these increases, the other one should also increase. Or if one of these decreases, then the other one should also decrease because they're going to move in the same direction. That's why we said they are directly proportional. All right, so let's look at our first practice problem. I did the math. This is completely improbable, but don't worry about it. Just go with it. A hot air balloon has a volume of 4 liters. So here we have a volume of 4 liters at 20 degrees Celsius. So we know that this is going to be a volume, and we know that this T over here, this Celsius is going to be a temperature. It says, what volume will it inflate to? All right, so we're looking for volume, and it says, will it inflate to? So would that indicate before or after? All right, if you said after, give yourself a pat on the back. So because this is our volume and it's after, this is going to be our V2. This is going to be then our V1. All right, now you see how this has a volume of this at that temperature. So that means that this volume and that temperature go together. So not only is that V1, but this will be our T1. It says when the temperature, okay, pause right there just for a second. All right, so we got our V1, our T1. Then it says, what volume will it inflate to when the temperature rises to 100 degrees Celsius? So this is the after. So this is going to be our T2. All right, so now we're going to write our variables. All right, we got a V1, a T1, a V2, and a T2. All right, our V1 we said was 4 liters. Here, I'll write that in red. Our T1 is 20 degrees Celsius. Our V2 is what we're looking for. So we're going to put X right there. All right. And then our T2 is 100 degrees Celsius. All right. Now, if you watched my earlier video about temperatures, you know we cannot do our math with gas laws in Celsius. We've got to convert those to Kelvin. The good thing is, it's an easy conversion. All you got to do is take the number in Celsius and add 273. 0.15, and that will give you your Kelvin temperature. So this ends up being 293.15, and this one over here ends up being 373.15. Yeah, I use zeros to make it easy for you. So now we're going to use our formula all right, which is V1 T1 equal V1 over T1 equals V2 over T2. So V1 over T1 equals V2 over T2. We're going to plug in. So our V1 is going to be 4 liters. Our T1 is going to be 293.15 equals, I'm not going to put liters there, sorry, because it's not necessary. All right, our V2 would be X and our T2 would be 373.15. All right. Now at this point, you can either divide and then multiply, or you can cross multiply and then divide. It doesn't matter which one you do. Try both ways, and the answer you should get is, so X is going to be equal to 5.09. All right, we found V2. V2 was, or V2, okay, good. Units, what unit goes here? So we know we found V2. So we're looking at volume, but we don't know what unit because it doesn't tell me. So if it doesn't tell you the unit for volume, look at V1 and make sure the units match. So if V1 is in liters, then our answer needs to be in liters also. All right, and truth be told, this is 1 sig fig, 1 sig fig, 1 sig fig. So this should really only be 5 liters if your teacher cares about sig figs. All right, we good on number 1? All right, let's go to number 2. So we have a basketball with a volume of 700 milliliters deflates to 600 milliliters. Oh, so it started here, ended there. So this is going to be our V1. It ended here. That's going to be our V2. At night, if the initial temperature is 325 K, good. It's in Kelvin, means we don't have to convert. But this says initial temperature. So this is going to be our T1. And it says, what is the final temp? So we're looking for T2. So again, we're going to set up our V1, our V2. I did that. I like to keep all my stuff together because in my brain, I'm starting mixing stuff up. So we got V1, V2, T1, T2. And that's going to be equal to, and then we're just going to go pull what we grabbed from the problem. So V1 is 7-Eleven, not the gas station. V2 is 600. T1 is 325 and T2 is X. I'm going to use the same formula because all we have are volumes and temperatures. So we're going to go V1 over T1 equals V2 over T2. All right, we're going to plug in our numbers. So for V1, we got 7-Eleven over T1, which is 325 equals V2, which is 600 over T2, which is X. All right, if you cross multiply, and let me say this, right, because this is somewhere my kids mess up. When you cross multiply, let me say 2 things. Number 1, the reason we can cross multiply is because it's a fraction equals a fraction. If this is a fraction times a fraction, right? If it was a fraction times a fraction, then you have to multiply across the top and then the top across the bottom. All right, but because it's a fraction equals a fraction, you're going to multiply like this, and then you're going to set your products. So when I multiply this and that, I need to set those equal to each other. So what do I mean? So I'm going to multiply the 7-Eleven X, right? I'm going to set this equal to the other one right here, 325 times 600, which is going to be, we'll just write it, 600, 325. Should be a parentheses right here. I ran out of space. All right, then you can just multiply and divide, divide, and get your X. And so what you should get that X equals 274.26. I got some notes over here on the side, and I confused myself. Oh yeah, that makes sense. All right, and we know because my volume decreased, right? So my temperature should decrease. All right, speaking of temperature, that should be in Kelvin. All right, and then if we're looking at sig figs, this one has 3, 1, and 3. So our answer should really only have 1. So that would really be, I'm going to go backwards because I'm running out of space. Oh, I guess I can write it right here. So I'm really only going to look at that. So that would be, the 7 would make the 2 a 3. So that would really be 300K. Again, that's if your teacher's looking at sig figs. If not, then that answer is probably good. If you're looking at sig figs, then go with that one. All right. So that is Charles' Law, explained in a quick nutshell. Stay tuned. I'm finna drop some worksheets with like full worksheet with full video, because I know on some of these channels they give you a little help with that, getting a practice problem. So I'm trying to give you all the practice problems you can get. All right, it's gonna be me and my crew, Coach Jakes and the crew. Like, follow, tag somebody. Let me know if this helped. Peace.